And now we're going to number 10. Are there any more questions on this before we go on? All right, so let's keep on going to number 10. So on number 10, let me go ahead and write this equation here. We have x minus 2, number 10, x minus 2 over x plus 4 plus x plus 1 over x plus 6 equals 11x plus 32 over x squared plus 10x plus 24. Okay. So on the left side we have fraction plus fraction, unfortunately different denominators, we'll address that in a second. On the right side we have one big fraction. So we have fraction plus fraction here, one fraction here. Anytime you have an equal sign with x's on one side in a numerator and denominator, in other words, anytime you have a fraction equal to a fraction, it is highly beneficial to cross multiply. This will be a great problem for cross multiply. However, we cannot cross multiply yet. Why can't we cross multiply? Because this is two terms. We need this to be one term, then we'll be in good shape. So if we could combine this into one fraction, sorry, 1 second. Just got a quick message. Okay, so if we could combine these into one fraction and have one fraction equals another fraction, we'd be in good shape. So let's see again. How can we combine these into one fraction? Well, we just did it on the previous problem. What did we do? We found a common denominator. Unfortunately, finding a common denominator here would be painful. So there is a nice shortcut that I learned from my 10th grade teacher. Unfortunately, it seems like other teachers don't teach this, but here's how she taught me to do it. It's an excellent way. Anytime you have two fractions, addition, subtraction, doesn't matter. Here's how you combine them into one. Take the denominator of the right one times the numerator of the left one. So x plus 6 times x minus 2. Then bring down the sign. So that's a plus sign that stays there. Then multiply the denominator of the left one times the numerator of the right one. And finally, divide by the two denominators multiplied by each other. You said it.
Does it matter which one you put first?
Yes. Yeah. It's easy to be first.
No. I mean, like, even when doesn't matter when you put like x
Here?
plus 4. No, on the grade. Doesn't matter if you put x plus 4 on the side. Like.
No. Because multiplication, no, it's fine. All right. And of course, this is equal to, and then once I put the equal sign, I'll review how to do this again, because this trick is excellent. So all we did here is instead of going through the whole process of common denominator, multiplying everything out, blah, 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 we use a shortcut. Shortcut says this. Take the denominator of the right one times the numerator of the first one. Bring down the sign, whether it's a plus or it could have been minus, doesn't matter. Then take the denominator of the first one times the numerator of the second one. All divided by the denominators multiplied. Works every time. Now, this is ready for cross multiplication. However, the cross multiplication here would be a pain. Imagine multiplying this, combining them, multiplying by this times this, then combine. It would be a long nightmare. 10 minutes of algebra would almost guaranteed make a mistake. So rather than just jumping in, life is all about making hard problems easy. You look for the shortcut, and here's the shortcut. Factor this. Factor this. And you see something very nice happening. This, if you factor it with the box, will give you this. And that's the beauty. Again, you can get this from the box. You can do the factoring in the box if you need to, or you can begin to try to push yourself away from the box. So now let me rewrite this and we'll see why this was so helpful. So rewriting on the next page. Rewriting on the next page, we've got x plus 6, we've got x minus 2, we've got x plus 4, we've got x plus 1, we've got x plus 4. I'm just rewriting the left side, and on the right side, all of these problems that we give you, they're going to work out nicely. I'm not going to give you something crazy. So now we have a fraction equal to a fraction where the denominators are the same. If you think about this intuitively, if two fractions have the same denominator, and I tell you they're equal, two fractions have the same denominator, and I tell you they're equal, the numerators must also be equal. X must be 1 here. In other words, this must equal this. We don't even need to worry about the denominators. They're already equal. Any questions on that logic before I go forward? Okay. So, the denominators are already equal. So set the numerators equal to each other. And this is solvable. And here I'm going to release you all on your own for 2 minutes. Multiply this with the box, multiply this with the box, combine like terms, bring this over here, solve for the roots. 2 minutes, we can do this. Let me freeze it. I'll unfreeze here in a sec. Okay, so here's what I got in the first step. So here's what we've got in the first step once I've done the combining on the left side. So any questions here before I go forward? If you got this, then begin working with the right side. Bring it over and so on. Any questions before I go forward? Here's where I am now once I brought the right side over to the left side. If you've done this, then factor it. Now you can solve for the roots. I factor out the 2 first. Zero product property here. Zero product property again. Let me stop here with questions. So we combined like terms on the left side, and we brought stuff from the right over to the left, and then we combined like terms, factored out the 2, zero product property, then factored this, zero product property again, and found the roots. Questions? Questions? Now, many people, myself included, thought these were the answers. Good thing I teach Lucio. He told me correctly that this cannot be an answer. Why can't this be an answer? Negative is fine. Think back, look at the problem. Why does this not work? Try to channel your inner Lucio. Channel your Heisenberg. Right, as George, Mariah, and Chepe were saying, we've got x plus 4 here. If I put negative 4 here, this is 0. Undefined. Not possible. Please understand, you need to check the solutions with the original problem. Negative 4 does not work. So this is the only solution. Please note, you must check. Questions? Okay. So that was the algebra. That was the algebra review. Hard algebra problems, but that was review. Now we want to get the new piece. The new piece is the following. If you flip to page 9, it's where we have the new piece. I'm going to do problems 2 and 12. These look brand new. I'm going to work through them though, and you'll see that it's really just building on stuff we've already done. So let's start with problem number 2. These are just equations that instead of having just an x by itself, it has cosine of x. That's it. Let's start with number 2. 2